Hello guys, my name is Viha Suhas Bhatt and I'm studying in SVCE. Today we are going to talk about bubble sort. So what is the agenda? What is brute force approach? Introduction to bubble sort, algorithm, pseudocode, examples, advantages and disadvantages. So what is the brute force approach? A brute force approach is a straightforward problem solving technique that involves systematically trying all possible solutions until the correct one is found. So this method is simple to understand and implement. It does not require any complex algorithms or data structures, making it a valuable tool for simple input sizes, prototyping and testing. It cannot be used for large input sizes. Despite its simplicity, brute force is typically inefficient, especially for large problems, because it explores every possible candidate, which leads to exponentially increased time and resource consumption. Examples for brute force approach are password cracking. So we try all the possible combinations of characters until we find the correct password. Next is introduction to bubble sort. So what is bubble sort? It is a simple comparison-based sorting algorithm used to sort a list of elements in ascending or descending order. It operates repeatedly, stepping through the list, comparing adjacent pairs of elements and swapping them if they are in the wrong order. This process is repeated until the list is sorted. So the simple way to understand and implement bubble sort is like this. So it's one of the most straightforward sorting algorithms, making it an ideal teaching tool for introductory computer science courses. Next is comparison based. It compares adjacent elements and swap them if they're out of order. In place sorting, so it sorts the list without requiring additional storage space, making it space efficient with an O1 space complexity. Next is algorithm. The first step is to compare adjacent elements. So we start from the beginning, the left side of the array, and compare the first element with each element and make adjustments or swap adjacent elements depending on the need of ascending or descending. So if a pair of the element is out of order, then we swap them. Next, this process is continued throughout for every element in the array. Then repeat the steps 1 and 3 for the entire list as many times as necessary until no swaps are needed during the complete pass through of the list. Next is the pseudocode. So as we can see here, we have an array from 0 to n numbers for which for every I, that is every element in the array 0 to n, we swap if there is if the first number is greater than the second one. If j for an element j from 1 to n minus 1, that is one number less than the total number of elements in the array, then we swap a of j with a of j minus 1. Next, if we have already swapped, then we break out of the loop and go to the next element. So steps of pseudocode. Initialize swapped to false. Iterate over the list from the beginning to the end. Compare each pair of adjacent elements. If the elements are in the wrong order, swap them and then set the swapped to true. Repeat the process until a complete pass through the list results in no swap. This brute force approach guarantees that the list will be sorted by repeatedly pushing the largest unsorted element to its correct position with each pass through the list. Despite its inefficiency, bubble sort is often used in teaching basic sorting principles due to its simplicity. Here's an example. So we're considering an unsorted list or array given here. So 5, 1, 4, 2, 8. So in the first pass, we're checking 5. We're comparing 5 with the second element, which is 1. As 5 is greater than 1 and we're sorting the list in ascending order, we swap the 2. Next, we again check 5 with the next adjacent element, which is 4. As 5 is again greater than 4, we're swapping the 2. The same is done till we reach a place where 5 is smaller than the element adjacent to it, which we can see in the fourth step where 5 is smaller than 8. Thus, there will be no swapping. In the next iteration, we check again, make sure that 5 is greater than all the elements to the left of it and lesser than all the elements to the right of it. In the second pass, we're checking again with the next digit, which is 1. We're checking it with 4. As 1 is lesser than 4, there will be no swap. Next, we move to the next element and check that with its adjacent element. So we're checking 4 and 2. So we're comparing 4 and 2. As 4 is greater than 2, we swap the 2. Next, we're checking 4 with 5. As 4 is lesser than 5, there will be no swap. Again, we go to the next element and check or compare it with its adjacent element. As 5 is again lesser than 8, there will be no swapping, and we have finally received the sorted array. In third pass, again, we do check to see if all the elements are sorted perfectly, and then this gives us the result of the sorted ascending ordered array. So what are the advantages of Boolean sort? Simplicity and ease of implementation. Boolean sort is one of the simplest sorting algorithms to understand and implement. Its straightforward approach makes it an excellent educational tool for teaching fundamental concepts of sorting algorithms and algorithm design. Small memory usage. Bubble sort is an in-place sorting algorithm, meaning it requires only a constant amount of an additional memory space of O1. This can be beneficial when working with systems with limited memory resources. Best case efficiency. In its optimized form, bubble sort can be very efficient for nearly sorted datasets. When the list is already sorted or nearly sorted, bubble sort can run in O of n time by detecting that no swaps are needed during a pass. Stability. Bubble sort is a stable sorting algorithm, meaning that it preserves the relative order of equal elements. This property is important in certain applications while maintaining the original order of similar elements if necessary. Next, a few disadvantages we see in bubble sort. High number of comparisons and swaps. So bubble sort performs a large number of comparisons and swap. As we saw in the example, it checks each and every element with each and every element in the given array, which includes a lot of comparisons and a lot of swapping, especially for lists that are not nearly sorted. This results in highly computational overhead and can significantly slow down the sorting process. Next is not suitable for larger lists. Again, because it compares each every element with every other element in the array, the larger the number of elements in the array, the more time it's going to take. So due to its inefficiency, bubble sort is not practical for sorting large lists. The time required to sort large data sets increase rapidly, making it unsuitable for most real-world applications where performance is a concern. Next is no advantage with random data. Well, unlike some other sorting algorithms like merge sort and quick sort, bubble sort cannot adapt to certain patterns in the input data. It does not gain any advantage with random data and will always perform poorly in the worst case scenario. Next is redundant comparisons. In many cases, bubble sort performs redundant comparisons even after the list is sorted. Like we saw in the example given, after phase 2, the list was already sorted. But as not all elements were compared to every other element, it did take another iteration to compare all the elements. Although optimized versions can detect if the list is sorted early, the basic version continues to compare elements unnecessarily, wasting time and storage. Thank you and have a great day ahead.